Hi, my name is Chelsey Smith, a computer science major at Dixie State University. Today I'll be showing you my senior project, which is a 3D game concept. When deciding what type of project I should tackle, I thought about it. What can I do that would be challenging, something that I can learn a lot from? Then it hit me. Try a 3D game. Why not? I've always wondered what type of work goes into making a game. The ins and the outs, who does what. And with this project, I was able to learn all the aspects of game development. My initial goals for this project were to have a game with the following features. I wanted a 3D world with a top-down isometric view. Models that had texture mapping and animations applied to them. A flashy physics-based particle engine, lighting effects, enemies that had artificial intelligence that reacted with the player in the world. For my code demonstration, I will walk through the events that are triggered when a player executes an attack. First, the controller's input is processed. We see that the B button has been pressed. We will now forward the attack type to the game engine. Next, we switch through the given bullet type, first verifying the player has enough mana to perform the attack. We then create a new bullet instance, passing in the player's position, the direction of the bullet, as well as many other parameters. Finally, we consume the mana and play the sound effect. In the update function, we check each bullet against the baddies to determine if a collision has occurred. If it has occurred, we damage the enemy and deactivate the bullet. The next step is to render the bullet. First, we apply any time-based effects. Next, we apply scaling, rotation, translation, and transformations to the model. Finally, we can render the object. As exciting as raw code is, the real magic of a modern game engine comes from its shaders. And now I will demonstrate the creation of one. I will now explain how parallax mapping works. First, we set the coordinates of the texture. This affects how it is attached to a mesh. When multiplying this coordinate by a constant, we can tile the texture. Next, we feed a grayscale height map into the parallax class. This applies a displacement effect based on the white value of the image, with white yielding a larger displacement than black. Finally, we feed the displacement map into the RGB texture map. As you can see, when viewing the texture from different angles, it now appears to have depth. This gives the environment a more natural and realistic look. I will now demonstrate the game in action. I do apologize for the poor recording quality. Apparently, Universal Windows apps don't play nice with recording studios at the moment. Enjoy. All in all, I have completed all of my core tasks, along with a few hope and dream tasks. While the assets I'm using are merely placeholders, I was successful in applying texture mapping and parallax mapping to them. The animations are working, however, I have a performance issue when applying the mesh transformations to individual entities. To get around this, all of my enemies share the same transformations. I'm also very pleased with the effects I'm using at this point, the animated texturing and physics-based particle effects engine. I would like to add multiple spotlight system in the future. The enemies utilize a simple artificial intelligence system. They randomly wander around the world until the player gets in a close proximity to them, which causes them to chase the player. The sound and controller APIs have been fully implemented. Loosely utilizing a Scrum-based software development lifecycle, I was able to adhere to a predefined schedule. The project took roughly 145 hours and was split between research, coding, designing shaders, and assets. So what's next for my little purple teapot? Being pleased with the progress I've made, I plan to continue working on this until completion. The project was very enjoyable, and I learned a great deal about video game development. Thank you.